In this video, I'm going to give just a very quick overview of classes, objects, and methods. And so this is something I will discuss in a lot more depth down the line when I discuss object-oriented programming more fully. But before proceeding, I thought it would be useful to just give a very brief introduction to these ideas in C sharp. And so just very generally, a class is sort of thought of as like a description or a blueprint for objects. And classes will contain attributes and methods, which I will discuss a little bit here in a little bit. An object is an instantiation of a class. And so we have the class which sort of describes what this object is and what it can do. And then the object is when we actually instantiate it. We actually make an instance of that class, and then we can use that object for things. And the what we do to use it is we use the methods for it. So the methods are sort of what describe, so they are the description from the class of what the object can actually do. And so a method, as we will see, can take in parameters as an input. So we'll also see that there does not necessarily have to be parameters, but a lot of times you will have parameters. And then a lot of times class or methods rather will have an output type or return type. And that's a value that can then be assigned to a variable and used by other methods. But there doesn't have to be a return type. You can make it void so that there is no return type. And so when that method is called, it will just run through the code inside that method and then stop. There isn't something that it outputs really. It can sort of look like output sometimes, especially when you're using like the print method, and so it'll print something to your console, but that's not actually a return type, because a return type is something that could be then used, it could be used as like a parameter in another method. So you could continue sort of processing that data, where the void type will not output anything that could then be used by another method. And so here is the demonstration that I will use. So say we have a class that we are calling demonstration. It can contain these following attributes. So we could have a public string, and these public things that I keep using here, I'm not going to get into that right now. Those are called access modifiers. And so when I use public, I'm essentially just saying that other methods and other classes can use these things. These are public to use. So like I said, I'm not going to get into that right now. Just for now, just the public is so that I can use it in other methods and other classes and things like that. So these would be our attributes. So we would have public string, and then you see that I just have this name here, and I'm not setting it equal to something. So this is called a field. And so this is something that we can then sort of assign values later when we instantiate an object. The object will have this attribute, and then we could assign that attribute for that particular object. We could assign a name or a string to that attribute, and we could do the same thing here. So in this case, I'm sort of thinking of this as like a student name and whether they are present for the class. So we have the student name, so maybe Alice. Then we could have attendance, so true if they're present, false if they are not. But we see here I have these comments. The default for a string type here would just be blank. For the bool type, it would be false. And then we could have the following methods in our class. So we could have this addition or multiplication method. So this addition one takes in two numbers as parameters. Then it returns the sum of these two numbers. And you could have other code going on inside the method, and we'll see that more in the upcoming videos. But for instance, we could have, like if statements, if num1 and num2 are, some numbers, then we'd have one return, and if they are some other numbers, we could have another return, and so on. So there could be more than just this single line inside here, but this is just a demonstration. I'm just showing that we're taking these two parameters as input, and then we are outputting the sum. So the return is our sum of them. Then same thing for this multiplier. We're taking in these two numbers as input, and now we are returning the product of those two numbers. So we see we have this int here and this int here. Those are telling us what the return type is. So these are returning integers. You could also return float numbers, or you could return strings or characters, and we'll see in the upcoming videos, you can actually return data structures, so things like arrays and lists and dictionaries and things like that. So down here I have an example of a void type. Well, these should have semicolons at the end of these. Actually, no, they shouldn't. Never mind, because we have a body to these, so never mind. These shouldn't have semicolons after them. But anyway, so here we have this void here, and so I'm just printing these two attributes here. So if we call this my print method here, it will just print these to the console. And so we want to use these attributes and methods in another class, which we will call execute, which is where we will have our main method. And so the main method is something that is used sort of for testing the code, because that's sort of where the compiler will actually start. And so within the main method, we will see that we then call these other methods within the main method, because the main method is what is actually run. But in running the main method, you can call these other methods. So when we want to instantiate our class, which we're calling demonstration, we use this syntax. So demonstration, demo equals keyword new demonstration with these two round brackets afterwards with the semicolon there. And in this case, the demo here is just the name of our objects. And so that object has all of the attributes that are described up here in our class. So it has these attributes, it contains all these methods, so we can use these methods with that object there. And so what we see, because these have an input, or rather a return type, so we can set int num3, and then we equal demo dot, and then we have the method name here. So we're using the object demo, and we're using the myAdder method that is in that object. Then we're inputting 3 and 7 as our parameters. And so this num3 here will be set to 10, because we are setting it equal to this object using the myAdder on 3 and 7. And what we see is that the myAdder just takes the first number and the second number and returns the sum of them. And so this num3 is the return of this method. And then we see with this, we have num4, and we're using the my multiplier now with 3 and 7. And so num4 will be set to 21, since it's returning the product of num1 and num2. And so now I will actually put this into code so we can test this out. And so you see I already have the two classes here, our demonstration and our execute here. And so what we want up here is our public string and then student name. So we are we are initializing that field. Public, so we had public bool attendance, and so we are initializing that field. And so we see that this class now has these two attributes right here. And so then we will do public int my adder int num1 int num2. Then we will put the body in here, and we will just do return num1 plus num2. And so that will just take these two parameters and then output the sum of them. Then we also had our public int my multiplier. We had int num1, int num2. Then we had our body here, which was just return num1 times num2. Then we had our void method here. So we had public void my print. Then we just did console.writeLine student name, console.writeLine, and attendance. And so those were the methods that we use. And so now down here, the first thing we want to do is instantiate our method here into an object. So we will have demonstration demo. So we can have demo equals, then I'll just auto-complete it like that. So we can have int num3 equals demo dot my adder, and we'll do 3 and 7. And then so now, so the way we have this here, it'll just assign this num3 to the sum of those. We can see here that this is sort of blurred out or grayed out a little bit because we're not doing anything with it yet. So this isn't, if we ran this, it would not actually print it to the console. So if we want to see what we get there, we will have to do console.writeLine num3. And so we see that this will print it to the console. And so we see that we get the number 10 there, so it's just taking 3 plus 7. Then we can do int num4 equals demo dot my multiplier, and then we do 3 and 7. We'll do console.writeLine num4. And then when we run this, we will see now we get 10 from the adder and 21 from the multiplier. And so then what we can do, so we can do demo.myPrint. And so what we see if we run this now, so it's just giving us a blank for the name because that's the default, and then false for the bool up here for attendance, which is the default. So what we want to do is demo.student name, and so we can set that to Alice. Then we can do demo dot attendance and set that equal to true. Now when we run it, so now it gives us Alice for the name and true for the attendance. And so we see the syntax here. We're taking our object, which is demo, and demo has all of the, it contains all of the things we have up here in this demonstration class. So it contains a field for student name, it contains a field for attendance. We can use all of 3 of these methods for it. And so down here we just take our object and then we do dot student name, our field, and so we are assigning a value to that here. Then demo dot attendance equals true, and we are assigning a value to that. And what we can actually instantiate this class multiple times. So we could do demonstration demo2 equals new demonstration. And so this demo2 is now a separate object that contains all of these things as a description. But now, so if we did, for instance, demo2 dot my print, what we see is that this demo2 is actually going to have its own fields here. So this one, the name is blank and the attendance is set to false. So this up here is just a description of it. So we're not actually like up here sort of assigning this Alice and true to the student name and attendance. We are assigning those to this demo object here, which just has these things as sort of part of its description. Then demo2 is a separate object that does not have these assigned to it because it's its own separate object. And so I kind of have an analogy here that we can use. So, an analogy, so a description of a hammer is sort of like a class, where a particular hammer is the object, and then the methods would be things that the hammer can do. So, things like pound in nails or pry out nails. And so, I have this sort of pseudocode type thing going on here where we have the class of hammer, and so the class of hammer just contains description, a very sort of abstract description of what a hammer does. So we would have things like the attributes, which are things like the head, which is this sort of part up here, and then the handle, which is this part down here. Then we have the methods of what a hammer can do. So we have this pounded nail, which will be our output of using the sort of pound method, and it's taking in a nail as a parameter. And then, so I have this pseudocode here. So while nail is less than pounded, it's going to pound nail, and then it will return this pounded nail here. Then we have the sort of pried nail, which will take in a nail. And so while the nail is equal to stuck, it'll pry the nail and return the pried out nail. So then we can have our class here, which is like our tool belt, I guess you could say. So we want to put an actual hammer into our tool belt. And so we are sort of taking this hammer and making an actual hammer here through this sort of instantiation syntax. Then we are sort of building our actual hammer. So my hammer, we're making the head up here be made of iron. We are taking our handle down here and making it out of wood. Then so here I'm just sort of making this nail here, and we're saying that it's sort of an unpounded nail. So we could think of it as like a just a nail we take out of our box of nails. Then we do this nail here that we want, so we want a nail pounded into the wood here, and so we take our object, so we're taking my hammer, so we're actually grabbing my hammer here, and then we are using it to pound in this nail that we just sort of took out of our toolbox. So anyway, like I said, this is just sort of an analogy. So the analogy being that the class is sort of a description of a hammer, or even you can think of it like a blueprint of a hammer. So you're in a factory that builds hammers. You need a blueprint of a hammer, what a hammer actually is. Then this instantiation is sort of actually making actual hammers. So we made this hammer here, and we made it with a head of iron and a handle of wood. And then we have down here, this is what the hammer is actually doing, and it's giving us a nail that is pounded in. And we could see, like we had in our code here, we could make multiple hammers, so you could just keep instantiating more and more of this. So we could actually demonstration demo 3 equals new, and demonstration demo demo 4 equals new, and you can keep instantiating this class sort of as many times as you want, or at least as many times as you sort of have computer memory for. But anyway, that is just sort of a very basic description of classes, objects, and methods. You will see in the upcoming videos that I will just sort of be using this idea of classes, instantiating them as objects, and then using their methods as I talk about data structures like arrays and strings and stacks and queues and things like that. But anyway, I hope you found this video helpful, and I will see you in the next one.